Hello everyone, hope you're doing and welcome back to my channel. Today we're at day 21 of the March daily LeetCode challenge, and we have a very good question one of us. From here onwards, I guess the graph week is starting. This particular question is basically on the topic of the topological sort. Okay, and one more thing that I want to show you is that see the acceptance rate, it is around 56%. This I usually see in hard questions. Okay, in the hard questions I see this kind of acceptance rate, but this question has that. Okay, so definitely it is a birth question. Okay, see, you will have to learn the topological sort. Okay, only then it will be meaningful to try this question. Otherwise it will be very difficult for you to understand what is happening. Okay, why the topological sort is needed, I will tell that also. But before that, my request to you will be, see, it's slightly lengthy question, so please do go through it once and do not depend on me to read every word here. I expect you to read them and then come back to this video. Always the video link is in the description. Please take that and go through the question, read it once, see the examples, and then come back. Okay, but definitely I will highlight the important points, but still I expect that you read the question once. Okay, because see, I'm not creating videos for any income purpose or anything like that. My aim is to improve you. Okay, because see, I am taking out this time and creating videos. My aim is so that people get to a level where they can start feeling confident in the interview. Okay, that is my personal aim. Okay, so that's the reason why I'm not trying to waste your time as well as my time. Okay, as simple as that. Now coming to this question, see what we're given. See, you are given three inputs in this case. Okay, first input called a recipe. This is again a 1D component. Second input is called a resident, sorry, ingredients. It is this 2D component. Why it is 2D, I will tell you that also. And the third one is supplies. Again, it is a 1D component. So we have two 1D components and a single 2D component. Okay, now let us see each one of them in detail. What is recipes? Recipes basically means that it is the name of a recipe. For example, bread. Okay, it is a recipe. Now for each of the recipes you need some supplies. Okay, these are like basic supplies. Okay, so for example, the basic ingredients of any food, they are called supplies. Okay, that you can directly purchase it from market or wherever you want. And in this question they are saying that these supplies are available in an unlimited amount. Okay, so these are the basic supplies which are available in an unlimited amount. Okay, so what they're telling is, for example, see, in order to understand how the bread is made, you have to see the ingredients of the bread. Okay, so in this case, see, for the ingredients array you have to go to the zeroth index, because see, bread is in the zeroth index of the recipe, so you have to go to the zeroth index of the ingredients array to get the all the ingredients which are needed for making bread. Okay, in this case, to make bread we need two ingredients. Okay, yeast and the flour. Okay, yeast and the flour. So we'll have to see whether in the supplies these ingredients are present or not. One more thing very important is, remember, here you have unlimited supplies. That means each of the supplies mentioned here, you have unlimited amount of them. Okay, so you don't have to worry whether we have enough ingredients or not, we have enough supplies or not. We don't have to worry anything about it. Okay, if it is mentioned here and if you need that, then we have it. Okay, as simple as that. Okay, so in this case they are saying that we need a yeast and we need a flour in order to make a bread. Okay, and we have both of them here. Okay, as simple as that. So the question here is, return a list of all the recipes that we can create. Okay, you may return the answer in any order. Okay, note that two recipes may contain each other in their ingredients. Okay, this part is very important. They have not highlighted in the example number one, but when you go to example number two and example number three, this point becomes very, very clear. So let us go now. Okay, so here the answer is bread, because bread can be made because bread depends on these ingredients, and these ingredients are present in our supplies. Okay, yeast and flour, as you can see, they're present, so bread can be made. Okay, as simple as that. Now let us go to example number two. Okay, here there are two recipes. Okay, bread and sandwich. Okay, now if you see bread, like the previous question, bread depends on yeast and flour. Okay, in this case if you see, yeast and flour are present in the supplies, so bread can be made, point number one. Now if you go to sandwich another recipe, here if you see the ingredients, it depends on bread and meat. Remember, bread is not a supply. Okay, if you see, bread is not present in the supply. Bread is a recipe in itself. Bread is a recipe in itself. Remember that. That is what we are trying to tell you, that a recipe depends on another recipe, something like that. Okay, so in order to make sandwich, you will have to make bread first. Okay, once bread is ready, only then you can go for the sandwich, because if you see, for the sandwich the ingredients mentions that we need a bread and we need a meat. Okay, meat is part of the supply, as you can see here, meat is part of the supply, so that we can take directly. But in order to get bread, first of all we'll have to get all the ingredients which are needed for bread. Okay, these are the ingredients which are needed for bread. Okay, so the idea here is, first you will have to complete bread, and then you have to come back and try for sandwich. Okay, remember, if you cannot make bread, that is, if let us say the ingredients needed for bread cannot be obtained, then obviously you cannot make sandwich also, because sandwich depends on bread. Okay, so now with this, it's going for a graph. Okay, there are dependencies getting created, and now it's going for a full-fledged graph. Okay, in example number three, this point will become very clear to see. Here at this point you have seen only a dependence of one level. Okay, that means one component depends on another. But if you go in example number three, now the depth of the dependency is increasing. Okay, if you see here, same thing, bread. Okay, okay, you can go through it on your own, but let me tell you the important part. See, bread is needed to make sandwich. Okay, bread is needed to make sandwich, and both bread and sandwich are needed to make burger. Okay, I will again repeat, bread in this case is needed to make sandwich. Okay, if you see here, if you go for the sandwich, they are saying that we need bread in this. Okay, now for burger they are saying that we need both sandwich and bread. Okay, that is, these two are needed, only then we can go for the burger. Okay, so now the number of dependencies are increasing in this case. Okay, and so on. So how to tackle this question? Again, here you have to written how many recipes can be made. Okay, as simple as that, and we can return the answer in any order. Okay, so how to tackle this question? As I mentioned, here we have to do the topological sort. If you're not aware what is the topological sort, it basically means that which condition, that is, see, which node. See, I will tell you the like the technical concept, like the in order how we are doing that, I will tell you that. But before that, just understand, see, there has to be at least one recipe which can be made, just with the help of supplies. Okay, that is, see, if you see in example number one, with just supplies. Okay, in example one, with just the supplies, we were able to make the bread. Okay, as simple as that, because the ingredients were, coming directly from supplies. So there has to be at least one such recipe which depends directly on supplies, which can be created. Okay, then this particular recipe can be created. Now, whichever other recipes depend on this recipe, we can go for them next. Okay, and so on. So there has to be, we have to follow a particular order in which you have to do. Okay, so that is the reason why the concept of topological sort is coming here. Okay, I don't have any diagrams to show currently, but there are very good diagrams available in the Google. Just go and search topological sort. Now, see, nowadays you can even go for the AI platforms. Okay, for example, you have the Gemini, you have the open AI platform, ChatGPT. You can go and just type the word topological sort and also some images. It will show you a lot of examples and a lot of images. Okay, you can go for that and see here what we are doing. Now, coming to the solution part, see, whenever you go for a topological sort, we need two things of, see, it's a graph question, so we need definitely graph, and especially for topological sort questions, we also need the in order information. What is in order? See, this is something very technical to a graph and a tree. See, in order basically means that, okay, they have not given the diagrams here, that's why it's slightly difficult for them to explain. But in order basically means that, okay, let me take you some other example. Okay, let me take you another question, and here I will show you. Okay, this is not the question that I'm solving currently, but with this example I will show you. Okay, see, if you see this graph 0 1 and 2, okay, 0 has basically two edges. Okay, see, there are obviously bidirectional edges. Bidirectional means there is no edge. Okay, there's no edge pointing. Okay, that is, we cannot say whether the edge is coming towards 0 or it's going away from 0. Okay, we cannot say that. It's a bidirectional, so both the directions are possible. So in this case, you see there are two edges which are coming to 0. Okay, there are two edges come to 0, so we can say the in order of 0 is going to be 2. Okay, so number of edges which are being associated with the node, that will be the in order of that edge. Okay, in order of that node. Okay, so that is the idea that we're going to use, and this is the in order. Okay, now if you see, this is a default dictionary with the value being a list. Here it's a default dictionary with the value being int. Okay, now what we're doing is, first one taking the n, and then I'm processing all the recipes. Okay, I'm going from 0 to n minus 1. Okay, and then I'm going through each of the ingredients of the recipes. Okay, I'm going through each of the ingredients of the recipes, then I'm creating an edge. Okay, how I'm creating edge? See, edge is going to be very simple. Okay, the edge will be always from, see, the edge will be always from, see, in this case then it will not be a bi-directional edge. Okay, remember that, it will not be a bi-directional edge, it has to be a directed one only. Okay, so what I'm doing, see, it's going to be very simple. For example, let me go to example number one first. See, in this case, bread depends on these two, east and floor. So what I will do is I will create a node east and floor, and from east there will be edge going towards bread. Similarly, there will be edge from floor towards bread. Okay, that will indicate that if we have floor, we can go for and try the bread next. Okay, and similarly, if we have east, we can go and try the bread next. Okay, so there will be edge from east towards bread, and similarly there will be edge from floor towards bread. Okay, that is the basic idea. If you see what I'm doing, I'm going through each of the ingredients of the current item, current recipe, and then from graph of j dot append this name. Okay, recipe name. So what I'm doing, I'm creating edge from j, which is ingredient, towards the recipe name. Okay, simple as that. And since the edge is going towards the recipe name, okay, that means it will be in order for the recipe. Okay, so in order of the recipe, we are incrementing by 1. Okay, now see, whenever you create a default dictionary, always the value will be 0 by default. Okay, and similarly, so you can just increment it 1. Okay, I'm not initializing it, but we are simply incrementing it by 1, because whenever you are using it, by default the value 0 will be used. Okay, simple as that, right? Now I'm printing this to for your reference. Let me show you this first. Okay, in the, okay, let me go for example number one. Okay, in this case, if you see, so east has an edge towards bread, similarly floor has an edge towards bread, and for bread then in order is 2. Okay, because there are two edges coming towards bread. Okay, let us go to example number 2. See, in this case, east has an edge towards bread, similarly floor has an edge towards bread, and bread has an edge towards sandwich. Okay, bread has an edge towards sandwich, and even meat has an edge towards sandwich. Okay, so there are two ingredients needed for bread, and similarly there are two ingredients needed for sandwich. Okay, as simple as that. Okay, once this is done, okay, once this part is done, what we'll do now, we'll start the actual topological sort. Okay, what you're doing, see, I'm creating a queue. Okay, I'm creating the answer. Now what I'm doing, see, initially, like, see, since only the supplies are available to us initially, so initially we'll go for only the supplies. Okay, this is the initial part, then we'll start the actual part. Okay, remember, this is just the initial part. So what I'm doing, I'm going through each of the supplies now. Now for each supply, since we have a supply in unlimited amount, okay, that is mentioned in the question somewhere, you can go through it, but what they mention is you have the supply in the see, infinite amount of supply. Okay, infinite amount of supplies. Okay, so what we'll do is we'll go through all the supplies. Okay, that means all the supplies that are mentioned here, we'll go through all of them. Then, since we have the graph now, we know like which all recipes depend on these supplies. Okay, so we'll go for dependent recipes in graph of y. Okay, that is which all recipes depend on these supplies, we'll go through them. Okay, and since this supply is available, so we can say that, okay, even we can now go for that recipe. Okay, whichever depends on this. Okay, so we are doing in order of dependent recipe minus equal to 1. Okay, now we are reducing the edge. Okay, that is one by one we are removing the edges, something like that you can think of. Okay, once we have the supplies, we are just targeting the next node which is dependent on it. Okay, so we are removing this particular edge. Okay, in order of dependent recipe minus equal to 1. Okay, since we have the supply and we are using it now, so in any recipe which depends on it will now be ready to proceed. Okay, something like that. So we're removing this edge. Okay, now if after removing this particular edge, if the in order of that particular node became 0, that means this particular recipe is now ready to be created. Okay, so we are appending that in the queue. So in the queue, only those recipes will be appended which are ready to start. Okay, so queue dot append dependent recipe. Remember, this will happen only if this if condition is true, which means this recipe is now ready to start. Okay, if then in order of the recipe is 0. Okay, as simple as that. So once this is done, okay, once this is done, we will start a while loop. Okay, what is this while loop? This while loop will run till the queue is not empty. Okay, what I'm doing a pop left. One more thing is, see, here I've created double-sided queue. What is a double-sided queue? Double-sided queue means you can append and pop from both left and right side. Okay, that is from both left and right end. You can both append and pop. Okay, as simple as that. So that is the reason why it's called a double-sided queue. It will O of one operation in both the sides. Okay, even for left and right, you can append and pop from both the sides in O of one time. That you cannot do in a regular list. Okay, remember that. If you have to pop from the left in a regular list, that will take around O of one time. Remember that. Okay, so that is the reason why you can go for a DQ. Otherwise, you can pop and pop both from the right side in using a simple list also. That also you can do. Okay, that's up to you. Okay, in this case, I'm using the DQ. Right now, what I'm doing is, while this queue is not empty, this value will continue. I'm just popping the first element out from the left. This is going to be my current recipe. Okay, remember, only when the recipe is ready, we'll insert it in the queue. Okay, so whenever something is popped out from the recipe from the queue, that means this recipe is ready. So I will add this recipe to the answer. Okay, this recipe is added to the answer now. Since this recipe is now ready, that means all that other recipes which are dependent on it can also be, we can even consider them for starting. Okay, so what you're doing is, for dependent recipe in that is whichever recipe were dependent on the current recipe. Okay, that we will see if they're ready to start or not. Okay, so whichever recipe which were dependent on the current recipe, that we will see whether they are now ready to be started or not. Okay, so I'll do in order of the dependent recipe minus equal to 1, because see, again, same thing, whatever we did here, no, exactly same 3 lines of the code we are writing it here. So exact 3 same lines of the code. Okay, that is, now this idea here is, since the current recipe is done. Okay, that is the current recipe, it is now completed. That means, for example, see here in the example number 2, once bread is ready, you can go for sandwich. Okay, because sandwich requires a bread. Okay, if you see, sandwich basically requires a bread. Okay, so once bread is ready, we can think about understanding if sandwich can be started or not. Okay, as simple as that. So we are just seeing if we are just reducing the in order of the sandwich, let us say in this case by 1, when bread is ready. Okay, next we are checking if the in order of the you know the sandwich, okay, that is the dependent recipe is 0 or not. If it is 0, if let us say it is not 0, okay, even if the bread is ready, still the in order of the sandwich is not 0. In that case, what we can think of is, this is not ready to start as of now. Okay, so we'll ignore it. Okay, but if it is 0, we will append it to the queue and we will go to the next iteration of the while loop. Okay, this whole thing will come continuing till we have a single element left in the queue. Okay, as simple as that. Okay, so yep. So remember, whenever something is present in the queue, that means it is ready. Remember that part. Okay, it's not like only certain conditions satisfied and something like that. Not like that. Whenever a recipe is there in the queue, that means it is 100% ready. Okay, as simple as that. Only if it is 100% ready, only then we will insert in the queue. Okay, as simple as that. And then finally we return the answer, because see, if you see, we are going on appending the recipes here, and finally we return the answer. Okay. One more thing that I want to tell you is that, let us say there is a circular dependency existing. Okay, let us say this particular example. Okay, the recipe 0 depends on recipe 1 depends on recipe 2, and recipe 2 again depends on recipe 0. Okay, so there is circular dependency. In this case, none of them can be created. Remember that part. Okay, in a topological sort, remember, if there exists a cycle, then none of them will be listed. Okay, remember that. The way it is being implemented currently, if you see, only if the in order is 0, only then we are adding it to the queue. Remember that. That means only, remember, if it is not added to the queue, that means it will not be processed. So the time queue becomes empty will come out. Remember that. So only those elements which are not in a loop, only those will be processed. Okay, as simple as that. So that is how it should be done. Okay, and finally, if you see, we are getting the answer. So let me show you my solution. I've added some extra print statement just for your understanding. So if you see, Let me go to example number 3 now, the most complex one. So in this case, if you see, sandwich depends on burger, sorry, bread. Sandwich depends on bread, and burger depends on both of the sandwich and bread. Okay. So in this case, if you see, for bread there were two dependencies, for sandwich there were two, and for bread there were three. Okay. Now first we'll go through all the supplies. Okay, we'll which all elements, which all recipes only depend on supplies. First we'll mark them as completed. Okay, and then slowly we'll go level by level. Okay, for example, see, bread needs yeast and flour. Okay, so first we'll, yeast and flour are ready with us, so we'll mark bread as completed. Next, once bread is ready, okay, once bread is ready, we'll try to see which all recipe depend on bread. Okay, so even sandwich and burger, both of them depend on bread. Okay, but which is ready? See, only sandwich is ready because burger needs the sandwich. Okay, so burger is not ready, only sandwich is ready, so we'll go for sandwich. Okay, because both bread and meat are available, we'll go for sandwich. Once sandwich is completed, then we'll see which recipes now we can go for. Then burger comes. Okay, because burger needs both sandwich and bread, so both of them are now ready, so we'll go for burger next. Okay, so that is the order in which it will be created. As you can see in the answer, the same order we're following: bread, then sandwich, and then burger. Okay, as simple. But in this question they are not asking about the order as simple, but in the solution that I'm giving you, I'm even following the right order. Okay, so this is the actual order in which you should be creating. If this is a real world problem, then you have to follow the same order to create your recipes. Okay, as simple as that. So yeah, fun, that was all for this particular video. Here we learned about, okay, first of all, the topological sort. Okay, and the idea that we're seeing here is a kind of a BFS idea. Understand that you can call this particular idea as a BFS idea, but it's the in order part that we are involved in here. No, because of that it becomes a topological sort. Okay, indirectly a topological sort. So yeah, that was all for this particular video. I expect you to go and see the diagrams of a topological sort. The idea here is, see, topological sort means it's a kind of sorting. First of all, here we are deciding which recipe will come first, which recipe will come second, and so on. Okay, we are deciding those positions for each of the recipes based on the dependencies that they have. Okay, that's why it's called a sort. Okay, it's not a traversal or something like that. It's a sort. Okay, it's a sort very specific to graphs which have edges. Okay, here the edges basically represent the dependencies. So yeah, that was all for this particular video. This was a very nice question. Please do give it a try, because see, if you see the acceptance rate, which clearly tells you that whether how many people are able to solve it, around 56%. Even some hard questions have around similar level of acceptance rate, around 53 to or 50 or something like that. Okay, but definitely between 50 to 56, something like that. So this question also has similar acceptance rate. That means this is not something easy. So definitely try this out, because this kind of question comes as a level 3 question in your weekly contest. Okay, that is the question number 3 in your weekly contest will be of this much level. Okay, so if you solve this, you will be able to solve first 3 questions in your contest. Okay, so yeah, that was all for this particular video. And if you have any doubts, please do let me know, but I always try my best to give you the whole content, the full content in its whole. Okay, so yeah, that was all for today. If you like my efforts, if you like the quality of this content, please do subscribe to the channel. This really gives a lot of motivation to continue further. Today I am completing my 151 days, and because of your support this was possible. You really gave a lot of support. Many of you were asking a lot of good questions, and many of you were really motivating. Whenever I was bit hesitant to put a video because of my work schedule, still I was getting comments that why today's video is still not uploaded, by when it will be uploaded. After seeing those comments, I really get a lot of motivation, and I upload the videos. Obviously, remember, the first point is solving them. See, I'm not doing this channel for any income or anything like that. I need a passion, I need a reason to code. That's why I'm doing this channel. So yeah, friend, that was all for this particular video. And if you have any questions, please do let me know. See you tomorrow. Thanks a lot.